Imagine waking up one morning to find your compass pointing south instead of north, and you are in a world where GPS is useless, satellites are glitching, planes are rerouting midair, and cosmic radiation is blasting Earth, unfiltered. It might sound like science fiction, but it's rooted in real science. Earth's magnetic field has flipped before, and it will likely flip again. But what does that actually mean for us? Today, we're diving into one of the planet's most mysterious forces, the magnetic field, exploring what it is, why it's so important, what's happened during past flips, and what a future reversal could mean for our daily lives. The Earth's magnetic field is one of our planet's most vital and enigmatic features. Generated deep within the planet's core, it acts as a vast, invisible shield, protecting us from cosmic dangers and subtly guiding everything from migratory animals to our daily technology. But what would happen if this magnetic field were to flip, its north and south poles trading places? This question, once the realm of science fiction, is rooted in real geophysical processes and has profound implications for life on Earth. At its core, the Earth is composed of a swirling mass of molten iron and nickel. The movement of this conductive material generates electric currents, which in turn produce the magnetic field in a process known as the geodynamo. This field extends far into space, forming the magnetosphere, which deflects charged particles from the sun and cosmic rays from deep space. The magnetic field is characterized by two poles, north and south, roughly aligned with the planet's rotational axis. It is not fixed, however. The field wanders, pulses, and even reverses entirely over long geological timescales. The field is measured in Teslas or Gauss and is strongest near the poles, weaker near the equator. The magnetic field serves several critical functions: shielding life from solar and cosmic radiation. The magnetosphere deflects most of the solar wind, a stream of charged particles from the sun, that would otherwise strip away the ozone layer, exposing Earth to harmful ultraviolet radiation. It also protects against high-energy cosmic rays. Navigation. Many migratory species, including birds, turtles, and even whales, rely on the magnetic field to orient themselves on long journeys. Humans have used compasses, which align with magnetic north, for centuries to navigate land and sea. Technological infrastructure. Our power grids, satellites, and communication networks are all vulnerable to geomagnetic storms, which are moderated by the presence of a strong, stable field. For most people, the magnetic field is an invisible force with little direct impact on daily routines. We may check direction with a compass, but rarely do we consider the implications of the field on global technology. However, during times of heightened solar activity, increased auroras and disruptions to radio and GPS signals serve as reminders of the magnetic field's protective role. Has the field flipped before? Yes, the Earth's magnetic field has flipped many times. These flips, called geomagnetic reversals, are part of the planet's natural history. The record of past reversals is preserved in volcanic rocks and seafloor sediments, which contain minerals that align with the magnetic field as they cool. By studying these rocks, scientists have determined that the field has reversed hundreds of times over the past 160 million years. The most recent full reversal occurred around 780,000 years ago, known as the Brunhes-Matayama reversal. The process is thought to have taken thousands of years, during which the field weakened, shifted, and finally reversed. There is no evidence that this reversal caused mass extinctions or catastrophic climate changes. Life continued to flourish. A more recent, short-lived event is the Loschamp event, which occurred about 41,000 years ago. During this event, the magnetic field weakened dramatically and the poles briefly reversed before snapping back to their original orientation. This excursion lasted only a few centuries. The Loschamp event is notable because it happened during a period when anatomically modern humans were spreading across the globe. Studies suggest that during the Loschamp event, the field's strength dropped to as little as 5% to 10% of its current value, making Earth much more vulnerable to cosmic radiation. Some researchers speculate that this could have led to increased mutation rates or influenced human behavior, such as the extinction of Australian megafauna and the Neanderthals, but there is no clear evidence of widespread extinctions. Currently, there is a region over South America and the southern Atlantic Ocean where the magnetic field is unusually weak, known as the South Atlantic Anomaly. This area poses challenges for satellites and spacecraft, which experience increased radiation exposure when passing through. Instruments can malfunction or degrade faster, and astronauts aboard the International Space Station have noted higher radiation levels during these passes. So, is the field flipping again? Measurements over the past 150 years show that the strength of the Earth's magnetic field is declining at a rate of about 5% per century. The magnetic North Pole is also drifting rapidly, moving from Canada towards Russia at speeds much faster than in previous centuries. These changes have led some scientists to consider whether a new reversal is underway. However, field reversals are not sudden. They can take thousands of years to complete, and the current changes may be just part of the field's normal fluctuations. There is no definitive evidence that a flip is imminent, though the ongoing weakening, especially in regions like the South Atlantic anomaly, is closely monitored. NASA and other space agencies are particularly interested in the behavior of the magnetic field because of its impact on technology and human health. As the field weakens and becomes more complex, satellites, space missions, and astronauts are at greater risk from increased solar and cosmic radiation. During transitions or excursions, the field may become disorganized, forming multiple poles or weaker areas, which could leave parts of the planet more exposed. NASA is freaking out, not because of an immediate apocalypse, but due to the challenges a weaker, shifting field poses for spacecraft, power grids, and communications. More robust shielding, satellite design, and forecasting of space weather are all critical priorities. What would happen if the field flipped? If a reversal began tomorrow, the process would unfold over thousands of years. Here's what to expect. Weakening of the field. As the field begins to reverse, its strength could drop significantly. More cosmic and solar radiation would reach Earth's surface, especially near the poles and in weak spots like the South Atlantic anomaly. Disrupted navigation. Animals that rely on the magnetic field for navigation could become confused, potentially altering migration patterns. Human navigation systems that depend on magnetic north would need recalibration. Technological impact. Satellites and space-based technology would be more vulnerable to radiation, potentially leading to more frequent malfunctions, degraded electronics, and increased costs for replacements and repairs. Power grids could be at greater risk from geomagnetic storms, increasing chances of blackouts. No doomsday. Despite these challenges, the fossil and archaeological records show no evidence that reversals have caused mass extinctions or catastrophic events for life on Earth. Humans and technology would need to adapt, but life would continue. The Earth's magnetic field is a dynamic, living system that has protected our planet for billions of years. Its occasional reversals are natural, if mysterious, events that have happened many times without catastrophic consequences. While a modern flip would pose new challenges for our technology-dependent civilization, ongoing research and preparation can help us weather the transition. As we continue to study anomalies like the South Atlantic anomaly and monitor the field's strength, we deepen our understanding of Earth's magnetic heart and our own place within its ever-shifting embrace. Like and subscribe for more fascinating science facts.